Chances are, if you've turned on a light bulb or a computer, you've harnessed the power of some very ancient and very strange trees. The vast majority of the electricity produced in human history has come from coal, and like all fossil fuels, coal is made from the remains of extinct organisms that have been exposed to millions of years of heat and pressure. But in the case of coal, these organisms consisted largely of some downright bizarre plants that once covered Earth from Colorado to China. Meet the Lepetit Andreas, also known as scale trees. Named for their scaly-looking bark, scale trees were tall plants topped with crowns of branches that sported long, narrow leaves. They thrived during the Carboniferous period from 299 million to 359 million years ago, and they're partly why we call the Carboniferous the Carboniferous. This period is named after the carbon-rich layers of sediment that formed from countless millions of scale trees, ferns, and other early plants that died, piled up, and fossilized. You know these layers as coal. During the Carboniferous, much of the Earth was covered in lush forests and swamps, and this is where scale trees flourished, sometimes growing as tall as a 15-story building. Their remains have been found throughout the Northern Hemisphere, but they're especially common in North America, where fossilized roots, trunks, and leaves have been found from almost every stage of the plant's life cycle. And because we know so much about the anatomy of these trees, we know that they were very different from the trees you and I know today. For one thing, they had no need for seeds. This is because scale trees were a type of plant called lycopods, which originated way back in the Silurian period, before seeds were even a thing. Some lycopods are still around today, like the low-lying, water-loving club mosses and quillworts. But instead of having seeds, these plants reproduce by releasing tiny, single-celled spores. Scale trees produce cone-like pods that drop their spores into the water below to be whisked away to the nearest patch of soil. But lycopods were also the earliest vascular plants, which means they were the first plants to contain xylem, a special tissue that moves water and nutrients from the roots to the leaves. This tissue is what allows modern trees to grow tall and straight because it contains lignin, a rigid organic polymer that gives the plant structural support. But scale trees only produce a small amount of lignin, and they also had much shallower anchoring roots than today's trees. So how did they manage to grow so large without, falling over? Their secret was in their bark. The outer layer of the scale tree, which is called the periderm, was extremely thick and actually made up most of the trunk. This allowed scale trees to reach great heights, some growing as tall as 50 meters high and more than 2 meters across. But they were still a lot more delicate than the hardwoods you find in today's forests. A single storm could probably knock down a whole swath of them. And they didn't always look quite so majestic. As juveniles, scale trees looked more like giant spikes sprouting out of the ground. At this stage, they had no branches to speak of, so their leaves just grew right out of the bark in a spiral pattern. As the trees matured and shed their leaves, diamond-shaped marks were left in the bark, called leaf scars, giving the scale trees their name. So scale trees were weird by the standards of your modern oak or pine. But when you're talking about evolutionary history, you can't really argue with the results. Scale trees were built to grow fast and die young, allowing them to spread across North America, Europe, and Asia, leaving huge swaths of organic matter in their wake. At their peak, they made up nearly half of the biomass in Europe and North America, and provided food and shelter for the giant insects and early reptiles that called these forests home. But the scale tree's success may also have led to their downfall. Their vast forests pumped out huge amounts of oxygen, which was great for us animals, but at the same time, the scale trees were also sucking up tons of CO2 from the atmosphere. And back in the Carboniferous, many of the decomposing microbes that could break down the hardy lignin and release CO2 as a result had yet to evolve. So over time, scads of scale trees collapsed and piled up without decomposing, keeping much of the CO2 that they had taken up locked away in their tissues. In addition to really putting the carbon in Carboniferous, the storage of CO2 also created a sort of reverse greenhouse effect. Falling CO2 levels combined with a sudden burst of volcanic activity plunged the Earth into an early ice age. The resulting extinction became known as the Carboniferous Rainforest collapse, and the scale trees were among its casualties. A few species did manage to hang on in places like Asia and South America into the Permian period, but by 272 million years ago, the last of the scale trees were gone. Nonetheless, these bizarre plants left behind a big legacy. After living and dying in prolific numbers for millions of years, scale trees and other early plants formed a thick layer of carbon-rich peat across much of our swampy world. The peat was eventually buried, compacted, and exposed to extreme heat, turning into coal. And eventually, some hair hairless ape dug it up and burned it, releasing the energy that the scale trees absorbed from the Carboniferous sun over 300 million years ago. Think about that the next time you turn on a light or charge your phone or watch a video about natural history. As plants go, scale trees were powerful. What do you want to know about the story of life on Earth? Let us know in the comments, and don't forget to go to youtube.com/eons and subscribe. Now do yourself a favor and check out some of our sister channels from PBS Digital Studios. Your brain will thank you.